Hey class, welcome to the fourth unit of study. We're going into rational numbers, and if you don't know what the word rational numbers means, spoiler alert, we're talking about fractions this unit. We're going to take a lot of those skills that we applied, and we're going to apply them to rational expressions. That means fraction skills. Okay, so we're going to just do a little intro, and a little of this will be review, as you could probably tell from the warm-up. Hopefully this is all working correctly. Uh, but let's just go. I want you to model the fraction 1/2. I'm going to pause the video. You guys do the same. Model the fraction 1/2. So on your desk, what does that feel like? What does that look like to you? Go ahead. All right, so I don't know how you thought about this, but if you had to discuss, and this is designed for me to be in class in front of you guys and talking about, okay, having a reflection, what are some of the ways different people thought about the fraction 1/2? What does their mental model look like? Okay, so some people might have had something that looks like this. Come on, pull tab, you can work. Maybe not. There we go. An area of 1 being cut in 2. So this might be if you broke out like a pizza pie or a just an apple pie, something, anything like that, or any sort of shape, and you're literally cutting it in half. So this would represent 1/2 right here, and this would represent 1/2. Let me get my pen. This side would represent a half of the box, and this side would represent half of a box, right? Let's go to this next one. Different mental model of a fraction. Maybe a number line showing halfway between 0 and 1. This is kind of like a ruler, right? So at the very bottom of the ruler is 0 inches. Maybe perhaps this is 1 inch, right? Exactly between 0 and 1 would be the number 1/2. Also in decimal land, that's representing 0.5. That's a different mental model that some people might have thought of 1/2. So the fraction, the actual numerical value for 1/2 is right in between 0 and 1. Okay, let's pull out this other one here. Okay, and if you notice, okay, some people just might think of it arithmetically. So dividing the top number by the bottom number. It's literally the fraction 1/2 is 1 being cut in 2, 1 being divided by 2, which results in the decimal 0.5. Okay, if you just like to think of arithmetic, that's absolutely fine. That's absolutely what fraction is. A rational number is a ratio, it's a division being represented here. Okay, another mental model would be selecting one out of two possible items. So if you have two hearts and you take one, you are taking one out of two. So that's kind of more of a probability context, right? So when we're talking about probability in the spring and March, right? The probability of 1/2 is there's one chance in two that that heart got selected, or there is one favorable outcome out of the two. So that would be another way of thinking about the fraction 1/2, the rational number 1/2. Selecting exactly half of a larger group of things. Okay, so if you have 6 here and half of them are pink, 6 stars, half of them are pink, that means that 3 out of 6 must be equivalent to 1/2. 3 out of 6 must be equivalent to 1/2, right? So if you think about half of the population, right, that is exactly 50%. It doesn't matter what the population is, exactly one side is equal to the other. That would be modeling the fraction 1/2 as well. All right, and I know I'm starting with a very easy fraction of 1/2 to model, but that's okay. And the last mental model, if you are a money person, and I think everyone is to some extent here, $1 split two ways. So if you and I were going through the lunch line and we wanted to buy a bag of chips, but we wanted to split it, splitting up the cost would be $1 split two ways. We each owe each other 50 cents into this particular snack deal. All right, so those are just some mental models to think about fractions, and I've talked about some people, talked with some people individually recently when we did the algebraic monomials about some of those. Okay, so pause the video here. Let's see what our Math 7 skills look like in terms of our fraction operations. Do the ones that you know how to do. If you don't know how to do them, that's fine. Just move on. But I'm going to put up the answers to these, and I just want to get your the juices going and thinking about fraction operations again. All right, so really quickly, I've got the answers up now, and I'm just going to go through these very fast. So 2/3 take away 1/3. So I just made a little model of this. I cut my pie into thirds. I have 2/3 highlighted. Taking away 1/3 leaves me with 1/3 of the pie left. Those already have a common denominator. And the next problem, they don't have a common denominator. I'm talking about thirds and sixths. So the very first thing, if I have 2 and 1/3, you need to make 2 and 2/6 and take away one of those 6, which leaves you with 2 and 1/6. Once again, no common denominator with the adding and subtracting of fractions means that you need to make a common denominator. We're going to talk about how to do that in a second if you don't remember. So this one, you have -3/6 plus 5/6, which is a third. Multiplying fractions is this middle row of problems here. So when you multiply fractions, you're taking 1/5 of 4/7. Multiplying fractions is actually the easiest one. Multiplying fractions is no problem. Top times top and bottom times bottom. 4/35. On the next one, yes, you can go -63/91 and make your multiplication tough, but you can actually cross-cancel common factors. So just like we just got doing in the last week of the self-guided unit, you can cancel out any common factors in the top and in the bottom, even if they're diagonal from each other in a multiplication problem. It becomes 7/13. 1/5 of 30 is 6. If I take 4/5 of an inch and I divide it by 4, you have 1/5 of an inch. Okay? But ones that aren't as mental mathable are like these next two, where you might have to do a copy, change, flip process. So there's no such thing as division. There's only multiplying the reciprocal. So you have to copy, change the division to multiplication, and flip it to its reciprocal, becomes -12. And the same thing here. And this one's actually still a little mental mathable. How many times does 1/2 an inch fit into 10.5 inches? Well, there's 2 1/2 inches for every 1 inch. So that means there will be 2 for the first inch, 2 for the second inch, 2 for the third inch, etc. until we get to 10. So that makes 20 plus the extra 1/2, which would make 21. I'm actually going to show the copy, change, flip process for you on that. First thing to do here, if you have a mixed number, is to make an improper fraction. So we'll go ahead and make that 21 halves. And then instead of dividing by 1/2, let's actually times 2/1. I have common factors that can be canceled out there. And I have 21 times 1 is 1, and you don't need denominators. It becomes 21. Okay, let's move on. Right, so an essential skill that you need to know how to do. Oh my gosh, I can't talk this morning. That you need to know how to do for this unit is to make an equivalent fraction. So you can factor out any common factors in the numerator and the denominator. That should not be new news to anybody. We just got done doing that. Or you could actually multiply the numerator and denominator by any common factors to maintain an equivalent fraction. So let's go ahead and I want you to make some equivalent fractions to these two. I'll pause the video and come up with mine, and you do the same. Okay, so like we said, you can factor out any common factors in the numerator and the denominator. So I went ahead and did that first on both of these. So 12/16 can simplify all the way down to 3/4. And I highlighted 3/4 because that's the simplest version that this fraction can be. But you could have also divided them both by 2 and had 6/8, right? 6 on the top, 8 on the bottom, right? If 6/8 is a equivalent fraction, you can still multiply by 10 on the top and 10 on the bottom and make it 60/80. Just add a 0. Or if you like that pattern, make it 600/800. Because you multiply by the same factor on top as you do on bottom, you have made an equivalent fraction, right? It's still equivalent to 3/4. Every single one of these fractions is equivalent to 3/4. Or if you wanted to, you can multiply by an algebraic monomial by 2x on the top and 2x on the bottom to make it 24x/32x. Speaking of algebraic ones, let's factor out a 3 on the top and a 3 on the bottom of this next example and make it x/3. That would work. Or you can multiply by 10 on the top and 10 on the bottom, make it 30x/90. Or you could take your x/3 and multiply by 2/2 to make it 2x/6. right? I'm not changing the value at all. I'm just making an equivalent fraction, right? Or you can multiply by 4 on the top of both sides of your original fraction, make it 12x over 36. Moving on. Another essential skill is converting a fraction to a decimal. So this, if you forgot how to do this, you're going to have to actually consider this fraction to be a division and divide the numerator on the top by the denominator, the number on the bottom, to achieve the decimal representation of the fraction. So I'm actually going to continue to work through this, not pause the video, and show what we're talking about. So 3/5 literally means 3 divided by 5, or 3 whole pies split amongst 5 people. What a decimal version does each person get? The fraction version is obviously 3/5 of a pizza, but let's see. Okay, so we're gonna have to put 3 inside the hood, 5 outside of the hood. How many times does 5 go into 3? Well, it goes in 0 times, so I'm going to have to consider 3.0. Let's move my decimal up, right? How many times does 5 go into 30 now? Well, it goes in 6 times evenly. My long division is done in this case, and it's 0.6 is my equivalent decimal. What about 1/4? Well, 1/4 literally means 1 divided by 4. You might also call this a quarter, and you know the value of a quarter, hopefully, in dollars is, you know, that is 0.25, spoiler alert. But if you didn't know that, you're literally saying, how many times does 4 go into 1? It goes in 0 times. How many times does 4 go into 10? It goes in twice. Let's subtract the 4 times 2 is 8. Subtract the 8. Bring down the 2. All right, we're going to bring down an extra 0. How many times does 4 go into 20? It goes in 5 times, and my decimal version is 0.25. What about 7/12? 7/12. How many times does 12 go in to 7? Well, in this case, it goes in 0 times. I'm going to have a number that's less than 1. Hopefully that was not a surprise to anybody. That 7/12 is a smaller number than 1 is. How many times does 12 go into 70? Well, 12 times 5 is 60. That is the largest amount, so I'm going to have to subtract. 70 minus 60 is 10. How many times does 12 go into 100? Now we're testing our mental math skills. 12 times 7 is 84. 12 times 8 is 96. So I'm going to have to say 12 times 8 is 96. Okay, and then we are going to bring down our remainder of 4. How many times does 12 go into 40? It goes in 3 times. And maybe you could kind of see where this is going. My answer is looking like 0.583. How many times does 12 go into 40? It goes in another 3 times. Let's bring down that 0 again. How many times does 12 go into 40 again? I'm going to keep coming up with the same exact process. So this is a repeating decimal. This is going to, if I was a crazy person, I could keep finding more digits of 3 on into infinity. But I'm just going to leave this at 0.583, and I'm just going to put the repeating symbol on that 3 to make sure that the viewer knows that that 3 repeats infinitely. 7/12 is a rational number. It's a fraction, but it's 0.583. So there you go, turning fractions into decimals. But let's go the other way. Here's another essential skill. How about turning decimals into fractions? This is what you guys had a little bit of trouble with when we were talking about the scientific notation concepts a little bit before. So the note says to read the decimal aloud according to the last digit's place value. And some of y'all needed a little bit of a review on the place value name. So in case you didn't know, now you know, or here's a little refresher. The first digit in a decimal, behind the decimal, to the right of the decimal, I should say, is the tenths. Then it is going down by a factor of 10 in every significant place value. So that's your tenths. Let me actually write this sloppily, of course. Tenths. This is our hundredths. Hundredths. which is tough to say. This is thousandths, and the next place value would be 10 thousandths. The next place value would be 100 thousandths. The next place value would be millionths. So read the decimal aloud according to the last digit's place value. So in this case, our last digit is this 2, and what place value is it sitting in? It's sitting in the thousandths place. So I would read this as 782 thousandths. That's what I would say if I was not a robot. I was not a calculator. I did not say 0.782, right? I would read 782 thousandths. So what is the fraction that represents? That is representing 782 over literally 1,000. Denominator of 1,000. That's the fraction. Now, that's not as simple as that fraction can be, but that's it. You just read if you can read the place values of your decimal and just put it over whatever that significant place value is. In this case, it's 1,000. If it was one digit, it'd be tenths. If it was two digits, it'd be hundredths, etc. So let's reduce here. Let's see if we can reduce this by a factor of 2. My bottom will be 500, and my top, well, let's actually break out some long division again. Probably do this mentally. But 2 goes into 7 3 times. 2 goes into 18 9 times. Bring down the 2. 2 goes into 2 1 time. So it is 391 over 500. I think that's as reduced as it can get. Correct me if I'm wrong. No, that's as reduced as it can get. There's no common factors on the top and the bottom. Okay, we have one more essential skill, and that is comparing these fractions. Which is bigger? Which part of the pie would you like better? Would you want more of? Which has more, 9 out of 13 or 7 out of 11? Okay, and I'm going to pause the video and let you guys kind of work through this. Or you could say, which basketball shooter is better? The guy that made 13 out of 18 or the girl that made 17 out of 24 shots? Interesting. So think through this, and I want you to compare with a greater than, less than, or equal to sign. So some people, without the aid of a calculator, may have tried to do a whole bunch of long division here, which would be fine, and found the decimal part of 9, that 9 is representing out of 13, that 7 is representing out of 11, and figured out which decimal was bigger. That's fine. Other people might have used the previous essential skill and said that I'm going to have to find a common denominator of, in this case, whatever 13 times 11 is. But there's another fun trick to see which is better, and it kind of plays off of that concept of having a common denominator. So what you can actually do is, let's put a box up here and a box up here, and I'm going to cross multiply, if my pen will work. I guess it's not working. I'm going to, why isn't it working? Cross multiply. Oh, getting the pinwheel. As I was saying, we have to cross multiply here. 13 times 7, which is 91, and 11 times 9, cross multiply across here, okay, which is 99. And which box is bigger? Do I have 91 or 99? Well, in this case, they're pretty close, but this fraction is actually larger. 9 out of 13, 9/13 is the greater fraction than is 7/11. So let's do that on the other side here. Okay, might be a little tougher to do. You can break out your calculator if needed. 18 times 17 and 24 times 13. You could also just simply find a common denominator. 18 and 24 both go into 72. Both go into 72. This one 4 times. 18 is 72. And 3 times 24 is 72. And then so you'd have to make an equivalent fraction on the top, make an equivalent fraction on the bottom. And hopefully that will allude you to which of these is going to be the greater fraction. That's it for this lesson today, and that should be enough to get you going on the essential skills part of your homework. Don't forget to like and subscribe, by the way.